We have been researching atoms and what's inside of them and stuff like that. So tonight we will be telling you about them in facts and in our own words. So for the past 6 weeks, I have been studying molecules and atoms, the bigger ones. So there was nothing in space before, just a few loose particles buzzing around until the Big Bang happened. Then instantaneously, molecules, atoms, and other stuff were being made up. So what is a molecule? A molecule is a group of two or more atoms held together by bonds. What causes those bonds is a reaction when two atoms meet. Think of it like a drawbridge. When they meet, the drawbridge is meeting the other side. And then someone's practically throwing a rope down and tying it down so it won't come up. There's also different kinds of atoms, like lithium, helium, and stuff like that. And they make up everything. Look at your fingertip. There's about 2 billion atoms in your fingertip. And now I will introduce my friend Sean.
I'm going to talk about neutrons and inner and outer shell. So a neutron has, I don't know why I did that. A neutron has, the neutron is a subatomic particle, the neutron is a subatomic particle, and the symbol for this is N or NO, with no net of electronic charge and a mass slightly larger than a proton. So, see these little blue things? Those are neutrons. See these little red things? See these little blue things out here circling around? Those are electrons. Yeah. Each with a mass approximately 1 atomic mass unit. Yeah. A neutron has a core of +1. Now on to inner and outer shells. An atom has its maximum number of electrons in its outer shell. This means it cannot reach over and bother other atoms. So outside of these rings, there is another layer, and when that's full and it covers the whole atom, it cannot go over and be a bully to the other atom and take its electrons. Yeah. This means it cannot reach other bonds and bother other atoms. It belongs to a group called noble gases. When the outer shell has its maximum number of electrons in its electron shell are said to be full. And the inner shell of an atom are always full. So they're the cool ones who are always full, and they don't need to go over and bother other things. Yeah. If the outer shell has less than its max number of electrons, then it will not be stable and reach for other atoms to get its full outer shell. So that's the end of my presentation, but I have a pun for you guys. So, do never trust an atom. They make up everything.
Well, a baking soda and vinegar reaction occurs when the baking soda is applied. It's taking a lepton from the vinegar, which is an acid, and it's practically turning it into carbon dioxide and some water, and it's creating pressure to blow the cork off. And then Cameron almost gets hit by the cork.
Yeah, and then I laugh and run after the cork.
My thought on the nucleus is that it's the main power source of an atom. It is in the middle and the most important thing in atoms. If atoms did not have a nucleus, it wouldn't be an atom at all. It'd be something you can't see, dead on your body. Still, if we did not have any atoms on us, we would be nothing. If nothing had atoms, there would be no such thing as the world. There would be no such thing as space, planets, or stars. There are nuclear power plants that do split atoms and use them for energy. It is a very deadly thing to use if it goes out of control. Ions help keep track of the number of electrons that are inside of an atom. If it has too much, it's called a positive charge. If it has less, it's called a negative charge. Ions can also take atoms away or add more than it has. If you have less, it gives you more. If you have more, it gives you less. For the inner and outer shell, does the same thing. If the inner and outer shell don't have that many electrons, the ions give them more. If they don't have that many, ions give them less. No way around. Here's Ryan.
Okay, so I am talking about protons and leptons. A proton is a tiny particle, smaller than an atom. Protons are too small to see, even with an electron microscope. But scientists know that they must be there because that's the only way that we can explain how atoms behave. To give you an idea of how small a proton is, if an atom was the size of a football stadium, then a proton would still be smaller than a marble. Pretty much all protons in the universe got made very soon after the Big Bang. At first, there was just no stuff, just a lot of loose energy shooting around everywhere in the form of protons and larger particles like photons called bonds. These early bonds had tons of energy and a lot of them broken apart into protons and antiprotons. Most of these antiprotons eventually lost energy and hooked back into bonds again. But some of these antiprotons seem have gotten lost somewhere. And all of the mass in the universe comes from these leftover protons. There are 6 leptons, 3 of which have an electrical charge, 3 of which do not. They appear to be point-like particles without internal structure. The best-known lepton is called the electron. The other 2 are charged leptons called the muon and the tau, which are charged like charged like electrons, but have a lot more mass. History. For many of years, scientists thought that the atom was made with For many of years, scientists thought that the atom was the smallest particle possible, but then they learned that the atom was made with even smaller particles, electrons, protons, and neutrons.
Electrons and quarks. So let's talk about electrons. Electrons are a negatively charged subatomic particle. Take a battery, for instance. It has a plus and minus side, right? The minus side is an electron, and the plus side is a proton. For every 1 proton, there needs to be at least 1 electron to cancel it out to make it neutral. Protons are found in a cloud around the nucleus, this here, and they move so quickly around that it's impossible to tell where they are at one moment in time. They were found in 1897 by J.J. Thomson. Quarks. First, you need to know that there are 6 types of quarks: up quark, down quark, top quark, bottom quark, strange quark, and charm quark. Quarks are so small you can't see them even with an electronic microscope. But we know they're there because it's the only way that scientists can do certain experiments. To make 1 proton, you need 3 quarks. 2 up quarks and 1 down quark. And for a neutron, you need 3 quarks as well. 1 up quark and 2 down quarks. The first quarks probably came into existence around the time of the Big Bang. Before the Big Bang, there wasn't very much of anything. But then once the Big Bang happened, everything started pretty much, and quarks started mixing with each other to create protons and neutrons, and then after minutes, they started creating atoms to make hydrogen atoms and helium atoms. The end.